Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hanafi bin Zaini with student ID 2020495516. In this slide, I will present you about my lab report, magnetism. The first objective is to observe the magnetic field as the meter closer to the magnet. Second is to calculate the field strength when the number of loops in the electromagnet increase, and the last one is to calculate the field strength when the voltage in the electromagnet increase. What is magnetism? Magnetism is the force exerted by magnets when they attract or repel each other. Magnetism is caused by the motion of electric charge. This is the result from the experiment, and this is the graph that I plot from the result. In this experiment, the red compass needle point towards to south, and when the magnet was flipped, the red compass needle still point towards to the south, which means the red compass needle is south pole. The magnetic field increase when the meter closer to the magnet. The magnetic field magnitude is proportional to the density of lines. The closer together the field lines, the stronger the magnetic field. When the meter is about 1 inch away from the north end of the magnetic field is 2.26 G. And for the south, the magnetic field is same, 2.26 G. In the experiment using electromagnet, at the left side of electromagnet is the south, and because the red compass needle point to it, the magnetic field strength is increased when the meter more closer to the electromagnet. The amount of field strength increase as the number of loops increase. When the number of loops increase, it increasing the strength of the magnetic field. The amount of induced EMF pretend will be the sum of all the individual loops of the coil. So, 4 loops will be 4 times more induced EMF than 1 loop. The higher voltage, the higher field strength in an electromagnet. When voltage increase, current must also increase. Since the strength of all magnetic field is directly related to the current in the wire, the magnitude of the magnetic field will increase with an increase in voltage in the current. And the conclusion from this experiment, the magnetic field increase when the meter closer to the magnet. The magnetic field magnitude is proportional to the density of lines. The closer together the magnetic field lines, the stronger the magnetic field. The field strength increase when the number of loops in the electromagnet increase. The amount of induced EMF produced will be the sum of all the individual loops of the coil. The field strength increase when the voltage increase. Since the strength of magnetic field is directly related to the current wire, the magnitude of the magnetic field would increase with an increase in voltage in the circuit. Therefore, all the objective of the experiment was acceptable. Thank you.
Assalamualaikum, my name is Nuraila binti Zulkifli. My student is 2020469536. I'm a presenter number 2 and I will present about experiment capacitance. The capacitance theory is when a capacitor is connected to an EMF, the plate attach charge from the terminals of the battery. The amount of charge is governed by the geometry of the capacitor. For a parallel plate capacitor, the capacitance is given by where A is the effective plate area, the area effectively overlapping. D is separation of the plates, is electric permittivity of free space, and the last one is K, is the dielectric constant for the insulating material in the inner plate region. As we can see, this is a data for part 1. The data on the left is effect of the dielectric of area, and the data on the right is effect of the dielectric for distance. This is data for part 2, which is effect of the dielectric on the capacitor. The data on the left is connected to battery, and the data on the right is disconnected to the battery. This is graph for part 1 in this experiment. As you can see, this is the graph capacitance against area. It shows a linear graph. as the area increase, the capacitance increase. The capacitance is directly proportional to area. To calculate K, the electric constant, we use a formula in the graph we state. So the value of K we got 3.5, and then we calculate the percentage area using a formula was given, and the percentage area we got 0%. From the graph capacitance against the reciprocal of the separation between the plate, it shows a linear graph because the graph has been inverted. As the reciprocal of the separation between the plate increase, the capacitance decrease. The capacitance is inversely proportional to the reciprocal of the separation between the plates. Based on the graph capacitance against area, it shows that the graph is increasing linearly. When the area of the plate increases, the capacitance of parallel plate capacitor also increases. It is because a larger area of the plates are allowing more charge to be held by the plates. Therefore, a larger area able to store more charge. Based on the graph capacitance against the reciprocal of the separation between the plates, it shows that the graph also is increasing linearly. When the separation between the plates decreases, the capacitance of the parallel plate capacitor increases. It is because the positive charge on the plate exert a stronger force on the negative charge on the other plates, enable more charge to be held by the plates. We can conclude that when the battery is connected, the value of capacitance, charge and energy stored increase, while the value of voltage between the plates remain unchanged. But when battery is disconnected, the charge is constant, but the voltage between the plates and energy stored decrease as the capacitance increase. So in this slide is the formula for the capacitance.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aidri Edwina binti Ediros Elaya Idrus, student ID 2020854402. I'm presenter 3 and I'm going to talk about experiment 3, which is DC circuit. For the theoretical background for this experiment, for a certain piece of material with a fixed resistance, Ohm's law states that the voltage between two ends of the material is directly proportional to the current flow through material, V equal to IR. V is the voltage measured in volts, R is the resistance measured in ohms, and I is the current measured in ampere. It has three objectives. The first one is to measure the current and voltage for simple DC circuit. Second, to study series connection of resistor. And third, to study parallel connections of resistor. For procedure, it has three parts. Part 1, measuring the current and the voltage in simple DC circuit. Part 2, the series connection of resistor. And part 3, parallel connections of resistor. For the data part 1, measuring the current and the voltage in simple DC circuit, we can see that as the voltage increase, the current also increase, but the resistance remain unchanged. When we plotting the graph voltage against current, we can see that V is directly proportional to the I. For the data part 2, series connection of resistor, we can see that voltage change while the current remain unchanged. When we plotting the graph voltage against resistance, we can see that V is directly proportional to the R. For the data part 3, parallel connection of resistor, the voltage remain unchanged while the current change. When we plotting the graph currents against resistance, we can see that I is inversely proportional to the R. The discussion for the experiment, part 1, the equation I equal to V over R tells that the current flows through a circuit is directly proportional to the voltage, but inversely proportional to the resistance. Hence, when the voltage increases, the current also increases and vice versa. For part 2, we can come up with a few equations. For the current total equal to I1 equal to I2 equal to R3. For the voltage total equal to V1 plus V2 plus V3. And for the resistance total equal to R1 plus R2 plus R3. For part 3, we can also come up with a few equations, which is current total equal to I1 plus I2 plus I3. Voltage total equal to V1 equal to V2 equal to V3. While 1 over resistance total equal to 1 over R1 plus 1 over R2 plus 1 over R3. From the experiment, we can conclude that this experiment shows that every part of the experiment is based on the Ohm's law, which is V equal to IR. When the potential difference increased, the current also increased. Current and voltage in series and parallel give different readings. The higher voltage can be reached in series connection, while higher current can be reached in parallel connection. The current was measured by the ammeter, while the voltage was measured by a voltmeter. Resistance was measured by the formula V equal to IR.
That's all from our group. Thank you.